Hi guys, this video is going to be much shorter than the last one, so that's a plus. We're going to be talking about mixing acids, Kb, so how equilibrium relates to bases, and then we're going to talk about salts of acids and bases. So, when we mix a strong and weak acid, the complete ionization of that strong acid is going to overbear that weak acid. So the weak acid will be negligible. So for strong and weak, the complete ionization is enough. All we care about is the stronger one. Okay, but for weak acids, you only consider the stronger one. Okay, it does need to be significantly larger, but it will be. Okay, so when we look at these, first, you need to look at their Ka values. Also, don't forget water could be the stronger one, so water needs to be included as well. It is clear to me that HF is the stronger one because its Ka is bigger. So we're only going to do it for HF. So we do our Ka table with ICE. Okay, and they solve it. Once they find X, remember this is molarity, which is H plus. Then we can find the pH. So we completely ignored the hypochlorous acid, the HClO. Okay. I'm not going to ask you to do any of these. You just need to make sure that you understand that if there's two acids, you always only calculate for the stronger one. Like the concept, not the calculation. Okay, now we're talking about Kb. Kb is just like Ka, except we've got it for bases. So anything that's got hydroxide is going to be a strong base, and specifically group 1 and 2 on the periodic table. So like potassium and sodium, and then the group 2s, calcium, magnesium, barium. Okay, any of those first two columns, those are going to be our strong bases. And just remember that our strong bases are going to break apart completely because they're going to be completely ionized. It will be a strong electrolyte, and they will be able to accept the hydrogen. Okay, so if it is a monohydroxyl, which means there's only one hydroxide group, the concentration of the base is equal to the concentration of the hydroxide. You just calculate it. If there's more than one, so 2 or 3, normally 2, we're looking at, you have to times it by 2, because when they have a 0.1 molar of a compound, that means you have twice as much OH because of the subscript. Okay, that's one of the bad things about this. H doesn't do that. But hydroxide, because it's directly related and they don't come off the same way the hydrogens do, you've got to make sure you understand that the hydroxides need to be multiplied by whatever subscript they have. Okay, so here we're calculating what's the concentration. So the concentration for KOH will be the same. Which means the POH, which I'm going to solve, is 0.65. And remember, pH and POH equal 14. I'm going to subtract that from 14, and I get 13.35. Okay, and then B, however, the OH is twice the amount of the original, and that's because of the subscript. So I've got 0.003 molar. So our POH is not 8, sorry, 2.52. So our pH, 11.48. Okay, so it's not that bad if you go that direction. It's easier to go this way than to go through hydronium. Okay, that bottom one, barium hydroxide, which has 2 times. So our OH is 0.020. Our POH is 1.70. So our pH is 12.30. All right, for weak bases, though, we're going to have to do our equilibrium expression, our Kb. And remember, that's because only a very small amount break apart. Here is our general Kb expression. Remember, the larger the Kb, the stronger the base is going to be. Just like with acids, the larger the Ka, the stronger the acid. All right, so here we've got, and this expression is going to be the same. It's always going to be x squared over the initial base. Sometimes it's written as base. Let's just leave it like that, base. Base. Because remember when we do our, so NH3 plus water, it's going to break into NH4 plus and hydronium. And remember when we do our ICE table, I don't care about water, minus X, 0, 0, plus X, plus X. So this is just going to be X squared over that initial value because we're going to ignore our 0.1. So we do need our value for, remember I posted that table in week 3, so just look there. So there's our value, we plug it in, and then we solve for X. Remember, this is now the OH concentration. It also asks for pH, so we're going to take the negative log of that for POH. I get 2.86, sorry, 88 is the POH. Means our pH is 11.12. Okay, it's going to continue to walk through that. Remember, I said I want you to keep it only to 2 places after the decimal. Okay, we're going to do one more methylamine. Let me see if I can look up its Kb since I don't have that. Okay. So Kb, in this case, remember on quizzes and tests, I'm going to give this to you. Okay, so there's our methylamine. So I do our 4.4 times 10 to the negative 4 is equal to our x squared over 0.33. So x, which is OH, is I get 0.012 molar. So then we take the negative log to get POH, 1.92, which means our pH is 12.08. Okay, so these do require an extra step because you find OH, and then you have to go to POH and pH. Also, y'all, if we're doing a KB and you don't have a pH that's basic, you need to reassess. Okay, so here are our salts. We're going to go through this fairly quickly. So just remember that salts are ionic compounds. So they're going to have either a cation from a strong base and an anion from a conjugate base. and an anion that is the conjugate base of a weak acid. Those ones are basic. I don't like the way that's worded. Okay, so if we look at this, I've got sodium here, that's from sodium hydroxide, and I've got bicarbonate, that's from an acid. I would prefer it to be from an acid. Okay, if you've got a strong base and a weak acid, it's basic. If you have a weak base and a strong acid, it's going to be basic. So NH3 is a weak base. HCl is a strong acid, so this is a acidic salt. Okay, and just remember, the stronger the acid, the weaker the conjugate will be. Okay, so we're going to identify, are these weak bases or pH neutral? So you need to remember what it comes from. So we're going to go ahead and add a hydrogen to each just so we see what it is as an acid. So I've got HNO3, HNO2, and then HC2H3O2. Okay, so the top one, this is a strong acid, so this will be pH neutral once I remove that hydrogen. And then the bottom two will be basic because those are weak. Okay, so now we're looking at which ones of these are our basic or our pH neutral. So remember, you need to think which ones of these came from a strong acid. The one that came from the strong acid is perchlorate. So this one is basic. All right, just remember that you can relate Kw to hydronium and hydroxide, but you're also going to be able to relate it to our Ka and Kb. I remember that Kw is always that same number, 1 times 10 to the negative 14 at 25 Celsius. Okay, we're not going to do any like this. I'm going to walk through one. There may appear as an extra credit on the homework, but again, not for the test or quiz. So we want the pH of this, and the reason we're doing this is because it's a salt. Okay, so we plug everything in, we do our ICE table. Okay, but this time, let's say we know that acid was HCHO2, so we can plug the Ka in for that one to find the Kb. And really, this is needed if you're not given a Kb on the table. Okay, and remember we said it was basic because it was a weak base and a strong, or is a weak acid and a strong base, so this salt should be a basic salt. Okay, they're going to do the same thing, but for this one, we're going to be looking at HC2H3O2. And then you find Kb from Kw over Ka. And the Ka is for acetic acid. Okay, again, not going to be tested. Also, just remember, the stronger the base, the weaker the conjugate acid is going to be. So we're going to do the same thing with these. A strong base will be pH neutral. A weak base will give us a weak acid. So this one's going to be an acidic. This is group 2, so it's going to be neutral. And this one's going to be acidic. So it may demon. Okay. So again, group 1 and 2 hydroxides, those are our strong ones. So if it's not a group 1 or 2, it is acidic for the cation. Okay, so here now we're putting the salts together. If it's a strong acid and a strong base that are put together, It's going to be a neutral solution. Okay. If it's a strong base and a weak acid, it's going to be basic. So strong base, strong base, strong base. And then you look at the acid part and see. If it is a strong acid and weak base, it's going to be acidic. And then everything else, if they're both weak, we're going to have to do some calculations, but you will not do any of that. Okay, so here we're looking in this situation. These are both weak. So then you look which one is stronger. So Ka is larger than Kb, so it's acidic. So then you're just comparing the Kas versus the Kbs. So now we're looking. I've got Sr, which is strong base. I've got Cl, which is strong acid, so this is neutral. I've got weak base, strong acid, this is acidic. For C here, this is a strong acid, and that big methylamine is a weak base, so this is acidic. We've got strong base, weak acid, so this is basic. Then I've got weak and weak. So right now I'm going to say on a weak and weak, we can't tell. We'd have to look at the Kas and the Kbs and then compare them. Need help with that? Please let me know. So polyprotic acids, so there are some on the table that I posted that have more than one Ka. And remember, that's just because they have more than one H to lose. And when that happens, just remember the first Ka is always the strongest. Okay, and remember, most of the time we don't even pay attention to the Ka2 or the Ka3, just because they're so much smaller than the original Ka. And that's it. I hope you'll have a great day.